Hi, good afternoon. We have a few very interesting topics to talk about in this upload. But before we do, as always guys, I want to thank those people that are supporting us, and I want to give a special thanks to Susan in San Francisco. I believe we've got a connection with certain numerology, and just as a little thing for you, Susan, think about the 24 hours in the day. And in each one of those hours we have 60 minutes, and if you times 60 minutes by 24 hours, you're going to come up with an interesting number. And you can think of all these things as just coincidence. We're going to see the same numbers coming back to us, but I think there's more than just coincidence, and I think it's probably synchronicity, and that is a little bit spooky, really, when you think about it. How can things be so synchronized? But it's like I said, if you look at our universe, it's playing by a certain rule, and that is in numerology as well, in numbers, mathematics. The universal language is mathematics. So guys, let's get on with it. Look what we're looking at. Have you ever seen the Earth's jet streams behave like what we're witnessing right now? Unprecedented behaviour. Probably 1,500 to 2,000 mile wide jet stream coming straight off the equator right up into the northern hemisphere, and we can see lots of fragmentation over the northern hemisphere. But the important thing is we have to realise our Earth is in climate change, and I'm not a climate denier, and I don't believe any of you guys that are following what's going on are climate deniers, but we just disagree with the religion of CO2 and man-made climate change. We'll get into that a little bit more later on. But we're looking at the jet stream, and we know what's caused the problems in the jet stream. It's twofold. We've got a grand solar minimum, which is weakening the heliosphere of our solar system, and that in turn is allowing more cosmic radiation in. We've got a geomagnetic reversal taking place, or it could be an excursion, and we can't call it either way until we get there. And it holds its current, or it holds its final position when it's reversed. But it is taking place, and whether it's a excursion or a complete reversal which holds, where the poles from the north flip to the south, it is really irrelevant. It's what takes place in between, and what takes place in between is a weakening of the magnetosphere, and we're having a weakened magnetosphere to the point of about 20%, and we've been slowly but surely seeing a change over the last 5 months of a certain region on our planet, Hong Kong and the Gold Coast in Australia, show weakening signs of the intensity of magnetism there, and it has weakened just in these regions by another 7%. So we could be at already around 25 to 27% down on our magnetosphere. What that does is exactly what happens with the sun when it goes into its low solar output, and the heliosphere shrinks, more cosmic radiation comes in. But the Earth has a magnetosphere, and that's our primary defense, and when that goes down or starts to weaken, more cosmic radiation is increased, a lot more than what would just be if the sun's heliosphere was weakened. We have a compiling effect, and as a result of that, the jet streams are becoming chaotic, to say the least. It's incomparable. If I just quickly take us around this globe and show you the conditions of the jet streams, it is unbelievable. And what I'm going to do is I'm going to show you what happens when we get the jet streams travel so low. We have that cold Arctic air pushed down, and as a result of that, we have more snow in regions at southern latitudes or towards the equatorial regions. As we've been watching over the last year, snow has been increasing in quantity, and Arctic weather has been increasing in quantity at lower latitudes, and that's because when the jet streams are low, it brings down the Arctic weather. What we could be witnessing here is a return to the glacial period, and we are on the cusp of anyhow going back into that. We have for the last 12,000 years enjoyed an interglacial period where we've enjoyed warmer temperatures, and for a lot longer than we usually do when, you know, temperature spikes. If you look back over the records of the last 400,000 years, you'll see that when it spikes, it's only there for about a couple of hundred years, maybe 1,000 years, and then it drops. And when that drops, that temperature, you know, CO2 follows it. So, you know, I talk about CO2 just to divert a little bit from the jet streams for the minute. I talk about CO2 being a religion. You know, I'm not the only one. Dyson Freeman, who's one of the best minds still alive on this planet, he's in his 90s now, I believe, and he said it's a religion. And what does that mean? It's a religion because, you know, you have to have a belief if you've got a religion, and that belief could be in a God. Well, you might not necessarily have seen the God, or you might have witnessed things that have taken place in your life, but you know, you have to have that ultimate trust and belief in that thing. And what we saw was Al Gore, you know, 20 years ago, taking to the streets, getting people in large amounts of numbers to go along with his you know, his theory that CO2 was first of all responsible by man for burning fossil fuels and everything else, and as a result we've changed the climate. And it couldn't be any further from the truth. We've seen NASA manipulating the temperature data, we've seen NOAA manipulating the temperature data. They've even asked the British Geological Survey if they will adjust their temperature over history to match theirs, and I don't think they had too much luck with that, but I don't know where things stand right now with that. I mean, that was at least a while ago when I looked into this. But the point is this, is that the majority of the people that jumped on the bandwagon with Al Gore believed what he was telling them. A bit later on in this video I'll get the CO2 detector out and I'll put it out on the windowsill like I usually do, and we'll take an atmospheric reading of CO2. But what we have to remember with regards to CO2 is that, you know, the amount that we put out ourselves burning fossil fuels and all the, you know, if you put a total on it, it's probably less than 40 gigatons. But our ocean in 1 year will put out 800 gigatons. You know, what comes out the ground on land, you know, another probably 800 gigatons. So, you know, our contribution to the carbon in the atmosphere is so minute in any case. You know, how could we possibly have affected the climate through just adding that little bit of CO2 to the atmosphere ourselves? The thing is that what we've seen from NASA's photos of the Earth, it's got greener in the last 20 years. And that's probably a result of the CO2 levels creeping up from 300 parts per million to 400 parts per million, or maybe just a little bit over on any given day. And I don't think it's right that they just take on Hawaii CO2 levels on the top of a mountain about 7,000 feet in the air, because if you want to get an idea as to what is in the reservoir in our atmosphere, I think you've got to have multiple stations, and NASA do claim to have this. We'll have a look at CO2 levels as well a bit later on this, because all the data that comes from this North Skull program that we're watching, or simulator, all comes from NASA. And you know, we'll have a look at that and compare what they're saying in the UK with what we're getting as a reading outside. But the big point is this, you know, CO2 is not responsible for climate change. What is responsible for the jet streams which are changing our climate in turn is the influx of cosmic radiations. And as you guys know, we do have muon detectors now at the observatory. We're going to be putting one out in Brazil, one out in South Australia. We've also got, leaving the observatory today, another magnetometer which is going to Tucson, Arizona. And Scott is our new superstar who's going to house that for us. He's also offered a bit later on to house one of our muon detectors, radiation detector and a CO2 detector, so that we can start increasing the amount of data with reference to these different things that we need to look at, because, you know, there is some fraud going on from certain organisations that are changing the charts and the historical data, which is not how you do science. You have to record what you get whether you like it or not. If it doesn't favour your objective, then you just have to take it as it is. I'm sorry, but what's going on in NASA is they are matching up the temperature data to fall in line with the CO2 rise. The problem is with this is they're going to come unstuck again, and the reason why they're going to come unstuck again is for the fact that the Earth's temperature is cooling, and that is a result of these low-lying jet streams. The reason why they're low-lying is because there is more cloud seeding in there, so they're becoming laden with water molecules, water vapor, and as a result of that they got more lazier, and they're hanging further lower, and as a result of that we're getting more Arctic temperature come from the northern hemisphere. So let's get the CO2 detector out. Let's have a look at the CO2 on the detector, and then we'll come back, we'll go on to North School, we'll get the CO2 readings, and we'll see how accurate NASA are today. I've got to say, last time they weren't far off, but they have been caught out by being at least nearly 50 parts per million off what they are recommending. Just before I do that, guys, you can see the changes taking place on our Earth before your very eyes. You guys know it. You know that the seasons are changing. You know that on one given day, because of the jet streams, you can have your t-shirt on, and a couple of hours later you have to put your jumper on or a coat because the weather's changed in that short space of time. How does it affect us? If we merge, and we are likely to do that according to what we are seeing, back into a glacial period, we know it's on the cusp. It's expected because of the data that we've got at hand. We know that when it reaches a certain level, it flips. If we merge back into a glacial period, and we can see that we are very slowly creeping back into that, most of the northern hemisphere is going to go offline. And what I mean by that, the grids are going to get shut down because there has been no facility preparation whatsoever. There's going to be food shortages, and we're already seeing those. We're seeing crops in Canada still in the ground when they should have been harvested already, and the early winter has caught them out. And as a result of that, it affects the global economy with regards to the prices of foods. It's going to affect us right now in our pockets. It has been doing so for the last 5 years. You will have seen probably food double in price. And as a result of these two things, the grid and the facilities and the food shortages, what's going to happen is there's going to be a lot of public upheaval and disorder, and things are going to begin to break down because a lot depends on the weather. People's jobs depend on the weather. If you work outside, you can't do certain work. If it's groundworks, you can't do groundworks in torrential rain where the ground's just turning to mud, because you're just wasting your time. You've got to go back after that day and restart it again. So we're facing some real serious issues, guys. And you can see this jet stream today. I've never witnessed one so low, so wide in my entire time. It's coming straight off the equatorial region, straight up into the northern hemisphere, and it's splintering off all over the place. Our planet's jet streams have gone offline, and they are chaotic at the moment. And this can bring, depending on where they're coming from, if they're moving from the north to the south, they can bring a lot of cold air. It mixes with the subtropical regions. You get a lot of water and precipitation, and in turn floods. If they're moving from the equatorial region up to the north, you're going to end up with the opposite, only because it's getting into colder temperatures up there. It's going to very likely turn out to end up being snow, and as a result of that we can see more crop damage, frost, etc, etc. I think what we need to do is really seriously start thinking about our plan when all this happens, because I say this as less than 2 people. Two people. There's a bit more than that. There's less than 2% of the planet's occupants that are aware of what is going on, and probably 50% of that 2% or less are preparing for it. We're going to have to deal with a lot of zombies. Our neighbours are going to be after us for what we've got. The street that we live in is going to be after for what we've got. you know, when it comes down to that minute where they realise something very seriously has gone wrong, and this could be a global catastrophe in not, you know, weeks after that. So, you know, we need to start thinking about preparing for it, knowing when it's going to happen and where the places that are going to be affected first, and we need to have our plans set firmly in place. You know, I understand you guys, you know, you probably come here and you've got families and you try and talk to them, they won't have it. I know. I've got members in my family that know I've been doing this for a long period of time and think I'm a bit of a crank. But at the end of the day, you know, there's going to come a time where they're going to be put in a situation and they are going to be the first to knock on my front door. I know that. And I might not be here, so I might be already have left. I've left Dodge already. Okay, let's have a look at the CO2 readings for the day, then we'll come back on North Skull for a quick 5-minute look at what NASA are predicting, and then we'll wrap it up at that. Side, it's ranging between 435 to 439 parts per million. Just zoom in on that. At 441, it's gone up a little bit. And you know, I've done a radiation background check for us as well. If I can get the camera to zoom in on this so we can see, there you go. That's well within low limits, and of course an oxygen sample still shows 21.12%, creeping up to 446. So let's have a look on North Skull and see what NASA are saying, you know, the CO2 readings are and whether they're accurate again. What I have noticed is that it can fluctuate. I have had it at 380 parts per million on some days, and I think if you go back a couple of videos you'll see that. But let's see what NASA are saying on North Skull. So we're over at North Skull, we're looking at the data, which is, as you can see, sourced from NASA, and you can see the parts per million here, 443, and the location roughly where I am in the UK. So it's not far off being right, but like I say, it does change on a day-to-day basis. If you get a copy, or you know, you get yourself on North Skull, you can see that, and just by moving around the world, you can see it's at 410 parts per million there, you know, 433 parts per million, 427 parts per million. But what you'll rarely find on here is that it never shows when the CO2 is less than 400 parts per million. And that's a bit suspicious because, you know, as I've shown you guys, you know, we do get it. It goes down to 380 parts per million. So, you know, there's, you know, again, cherry picking of the results. 413 parts per million. Doesn't matter which darkest region you hit. Ah, here we go. There is a region that we found at 383 parts per million. So these regions do exist, but you know, on the whole, they're saying that the majority of CO2 is at 400 and something parts per million. But let me put that into perspective. There's a lot of trace gases in our atmosphere, and that makes up less than 1%. So it's totally irrelevant. The only thing that's going to thrive if we add a little bit more CO2 to the atmosphere, or, you know, we've had a long period of 12,000 years of enjoyment of warmer weather than usual, going back over, you know, 400,000 years. So this last 12,000 years has been one of the warmest periods on these peaks where we've had, you know, it go warm, CO2 rises, and then it drops into a glacial period. We've benefited from that, and what happens is when you have a prolonged period of 12,000 years of warm climate, it releases a lot more CO2 out of the oceans, and that's why it's gone up to 400 parts per million, or 450 parts per million, or just a little bit shy of that today. And you know, you can see it moving round because, you know, there's a lot of things at play here, guys. We've got ocean currents, ocean temperatures, and you know, temperatures of oceans at certain points of the earth that are lucky enough to have good weather are going to release more CO2 in them regions, and they're going to go up into the atmosphere and get carried over continents, you know, with the jet streams moving them, and we're going to end up with, you know, fluctuations in CO2 at different points. But the main thing is we shouldn't be concerned. You know, it's It's less than 1%. It's a trace gas, and there's lots of trace gases, and the only benefit that will come from adding a little bit more will be what we're seeing with the satellite photos from NASA, and that is a greener Earth. And who is against a greener Earth? Who doesn't want to see Earth flourish? Because when we had more greenness, we had more insects, we had more diversities of species, and surely that should be a good thing. Who would want that to be the opposite? If we took the 400 parts per million today and dropped it down to 150, we'd shut down the ecological system of all biodiversity, including ourselves, because we in turn rely on the vegetation that the animals eat for us to eat, or the vegetation that needs the CO2 to grow and produce our corn and wheat and everything else. Who would want to reduce it at this point? I'm in favour of increasing it. In fact, over the next couple of days I'm going to light a fire in the back garden, and I'll be pleased to be putting that carbon back up with all that wood I'm going to burn. I think everyone should have a good fire. We can sustain even a healthy life if we doubled the amount of CO2 from this point on. It wouldn't affect us at all. In my living room right now, it's over 1,000 parts per million. Are you telling me when I leave the front door later on that I'm putting myself at more risk because I'm in an atmosphere of 400 parts per million? Surely not. I'll leave it with you guys. It's been amazing. There's a link down there if you want to help support what we do. As you can see from just today, we've got magnetometers going out. We've brought the equipment to show you guys firsthand, and we've done it honestly. I'd have loved to have seen less than 400 parts per million just to rub it in NASA's eyes, but you know what? It is what it is, and you've got to record the facts as they are, and that is doing science. There's a link down there if you want to support us. I want to say big thanks to the patrons and the PayPalers, and I'll catch you maybe tomorrow. You guys enjoy the rest of your day. As always, bye for now.